Hello, ChemFam. We are going to start a new unit, which is called gas laws. And this is the introduction to gases, so we get an overall general idea of what exactly gases are. A few things about gases. We learned about solid, liquids, and gases, but we know gases of the three physical states, those are the most spread out. But don't forget, just because we often can't see gas with our naked eye, doesn't mean that it doesn't have mass to it. So gas does have mass. And if you wanted to prove that to yourself, take an empty basketball and a basketball full of air. Mass them both out on a scale. The one with air will be a little bit heavier. So gas definitely has mass. In fact, we'll learn later that the mass of the air above us pushing down creates atmospheric pressure, which sometimes makes your ears pop when you're going in a car up a big hill or in a airplane or down below water. Even there's pressure from the water as well, but that wouldn't be air pressure, that'd be pressure from a liquid. But the idea of pushing down from gas, that is because of the mass that gas has. All right, mass is also compressible, meaning that you can squeeze it and squish it. Airbags in a car is an example of that, right? Because the airbags go off and during an accident, our head hits the airbag, the air cushions us a little bit because it's compressible. And then don't forget, when you release a gas into a room or into a container, it completely spreads out and fills it. And we'll get into why that happens in just a little bit. But that's a good thing, right? Because if gas didn't spread out, maybe only certain parts of the room would have oxygen where other parts wouldn't. And you would be gasping for air or oxygen to breathe because you were in a wrong part of the room. But luckily, the oxygen in all gas spreads out naturally. A few other physical properties of gases is that gases can move past and through each other. The movement of gas and mixing up naturally in the air, that idea is called diffusion. All right. An example of that would be like if someone in the corner of the room sprayed some perfume. Slowly across the room, you could start smelling that perfume. Why? Because the gas of the perfume, the little particles, diffuse and actually spread out through the entire classroom. Now, eventually it'll diffuse and spread out so much that our nose can no longer sense it. But for a while, you could smell that, maybe that nice vanilla perfume scent across the room. Right. Another thing that we already talked about a little bit in the previous slide is that gases can exert pressure. Maybe when your ears popped, if you're going up and down in an airplane, again over a big hill or small hill or driving a car, that change in pressure can affect us a lot of times in our ears and center of balance. So we'll talk about why that happens as well. And the last thing is that of three phases, solid, liquid, and gas, temperature affects gas the most. Temperatures can affect the gas by increasing pressure, and we'll get into that as well. But on a hot day, our tire pressure is higher in our car than on a cold day. And also, we know like a balloon, if you buy a balloon inside the store and you bring it out in the cold of winter, that balloon starts to shrivel because the temperature went down. But when you bring it back in the house and it warms up, it can pop right back up and be full again. So temperature affects gas dramatically. If you ever played basketball in a warm room versus outside in the cold, the ball definitely bounces better in a warm room. And that's because the temperature affects the gas in a way to make it expand. And we'll go through that this unit on how these different things are affecting gases. Now, something we like to call the kinetic molecular theory is a great way for us to simplify and explain how gases act. There are 5 parts, all right, and we do make a few assumptions about gases in order to make our calculations easier and just use algebra. But even when we do these assumptions, it's a still pretty solid way. It's a solid way, basically, of explaining how gases should act. So let's go into that. Part 1 of the kinetic molecular theory is that we can assume that gases are tiny little particles, and the gases are either going to be individual atoms or molecules. So we just like to think of gases as tiny individual pieces. We also know that gases are incredibly small, those tiny little pieces, and in fact, they're super spread out. And that's why gases end up filling up their containers. Because they're spread out, they're not completely attracted to each other that much. But this gives gases, compared to solid and liquids, very low density, which is why gases tend to rise in the air, are definitely above solids and liquids because they're so spread out. So little pieces are what gas is made of, and those particles are very spread out. An important one in the part of the kinetic molecular theory. Kinetic is the energy of motion. This explains why gas particles, we assume, are in constant random motion. As long as there's energy in the room, those gas particles are constantly bouncing off of each other and objects. All right, so we know when we inflate a balloon, why does it inflate? Well, the air from our lungs goes into the balloon and it collides with the walls of the balloon, holding it up, right? Because of that collision against the walls, it causes pressure. That's why tires inflate, or balloons inflate, etc. Or an airbag can inflate. It's because the gas is pushing against the wall, giving it its shape. But the important thing is, as long as you have some sort of temperature, there's constant random motion going on of gas particles. In fact, that's why you feel warm in a room. The warmer the room, the more energy or kinetic energy the gas particles have, and those gas particles bouncing off of you give you that sensation of heat or warmth. The colder it is, the slower the gas particles are bouncing off of you, and therefore you feel cooler. Part 4 of the kinetic molecular theory is that even though this really does happen, gas particles do like to attract to each other at times. We are going to assume that they do not attract or repel each other, that they simply bounce off of each other. The reason we make that assumption is to make our lives a lot easier with the math. The calculations are easier. Now, in reality, we know that different particles are going to be attracted to each other because of things like London dispersion forces and things we've learned about already. But we are going to ignore that when talking about gases in order to make our calculations easier. So remember that whenever we do math with our gas law stuff, it is an assumption. It's still close to reality and the right answer, but it's not perfect, and that's because of this assumption. The last part of the kinetic molecular theory is that the higher the temperature, the more kinetic energy the gas has. So we say that the kinetic energy is proportional to the temperature. When temperature gets higher, the particles move faster. So as temperature goes up, so does the kinetic energy of the gases, all right? And that is directly proportional to what we call the Kelvin temperature. Now, you're used to probably degrees Celsius or degrees Fahrenheit, but there is one more unit called the Kelvin that we'll talk about more tomorrow in class. And that's just a unit or scale for measuring temperature that scientists like to use. There's actually no negative temperatures for Kelvin. So we'll get into why that is and all that. But what's important to know is the hotter it gets, the more kinetic energy a gas particle has, which means they bounce even faster, give off heat and warmth, etc., which is why you feel warmer in a warm room. So to wrap up this idea of the kinetic molecular theory in gases, what if the kinetic molecular theory wasn't true? How would driving a car be completely different than it is now? Well, think about that. If gases didn't act the way they did, you wouldn't be able to inflate your tires maybe, which means you wouldn't even be rolling on tires. Think about the safety of an airbag. If it went off, if gases aren't compressible in that, then you really couldn't use it as a cushioning device after a rough accident. Without gas particles spreading out naturally, when the car engine is trying to take the gasoline and turn it into tiny little particles so that it can be ignited by a spark plug and explode to push the pistons down and get your engine working, that couldn't happen if gases didn't act the way they did. So our lives would be very, very different if kinetic molecular theory wasn't true. Well, luckily for us, it is. It's just something we take for granted because we grew up around it. We're surrounded by gases constantly, which is why we can breathe. But since we can't see or really notice it, besides when it's windy or that, we don't really think much of it. But now you have a better understanding of gases and what they do and how they act. So now we can dive deeper into explaining the world around us when, say, for example, the temperature decreases. Why does the volume of the gas decrease as well? It all has to do with the kinetic energy of the gas. And that's why the kinetic molecular theory is important to learn about. All right. Thanks for listening, ChemFam. Have a great day. Best of luck.